Okay, I guess yeah. So we are live again, man. Right? Na hum tum ke almost bacan. Oh, so it Twitch is here and then how can I mute myself? Oh, I got it. Na hum tum ke almost bacan. Oh, so it Twitch is here and then Alright guys, I'm back. Mute myself. Okay, bitrate is not bad. Oh. How can I whisper? I mean, oh, I see you. I mean, how can I text you? Is there any way? Oh, yeah, here. But I guess it's only gonna work when Twitch is live. It's only going to work when Twitch is live, right? Otherwise, it's not going to work. Unstable? Well, go back over here. Okay. Okay, let's just switch to HackerRank for some time and yeah, right here. HackerRank. Updated. Okay, the minion game, we are doing the, let's do the unsolved and the, if they are available. Okay, XML find the score, let's try this one. So like you're given a valid XML documents and have to print its score. The first line contain and the number of lines in a document. One, two, three, four, five. Okay, so the feed and title. Oh, my glasses, I forget. The feed and subtitle tag have one attribute. Lang, right? So I suppose we have to search for the, so we got one over here, then we got one over here, two, then we have 3, 4 and 5, right? So I suppose if we search for something like there may be any level of nesting in XML documents. To learn about XML parsing, refer here. I would say we can just use we can just search for equal to's in there, maybe, you know, and then we can say, okay, so let's just convert it into a string first. We got string node, then we can search if this, let's try this thing if it works. Otherwise we're gonna switch our solution. If yeah, use encounter in collections, right? Okay, so I remember counter dot list, and then we have this thing, right? But I want to do this thing, right? So list. Okay, but it goes over a list or a dictionary, not. I guess the regex approach will be a better approach, just to search for something that an equal to after and before, right? Redot find all ye. Where is redot find all? Find all will be like start and more than one. No, we don't want to search this thing. I'll search equal to. No match, no import redot find all regex. Is this thing in that string? Is this thing is gonna give us a match, which is going to be this thing, right? Okay. So going back over here, redot find all, we have an equal to inner string of the node, right? Now we're gonna search print length of that list, right? Because it is going to give us equal to's. Okay, we need to take that input as well. Even though we're not dealing with it, we still have to take it. No, line length will be a better variable. Okay, import. Then we have the read find all this regex in string node of this thing. Then we have our this, and then we are taking the length of that thing one. Okay, so parenthesis is never closed. Ek to. Oh, we need one more parenthesis over here. Okay, let's run again. So end of file error, we have expected output this thing, then we have this thing, so we need to also take input as our oh, okay, so the point here is that first 6, and then for I in range line length, for I in range line length, then we have to convert it into an integer, right? And then we have to take another input for the lines, right? Line input is going to be an input, and what we're going to do is that we're going to add it to our main string plus equals to right is going to add it to that thing. And what we have to do, instead of going it on node, we're gonna say main string and then search for the equal to. Okay, what is our no response, end of file error, runtime error? There's something wrong with the Find the score of this. The next n line follows containing. So that's what we are doing. We are taking input. We are converting into an integer, which is going to be line length for I in range. This thing. We are taking the input again and again. Or we don't have to do this thing. Is this just... Let's try this thing. Because it's kind of confusing. In get attribute line 7 to be the main string. Why is it giving us the error? Okay, hold on. So they're calling us get attribute is going to be the hold on, this is crazy actually. Let's check what is a node. Okay, so element feed at this thing is the node. Can we convert it into a string or something like this? Maybe. Oh, you're given a... Oh, sorry, come back. Okay. So the point I'm trying to make is that you're given a valid XML document and you have to print its score. The score is equal to the sum of the score of each element. Sum of the score of each element. For any element, the score is equal to the number of attributes it has. The first line contains n, the number of lines, and so why we are getting this thing element feed at this point. So we have to specifically use something from here, xml.tree as e3. There may be level of nesting in XML. In order to parse and generate an XML element tree, use the following code. e3.elementtree, e3.form string. Okay. Print tree, sorry, print tree, not node. Okay, it should give me something like your output is nothing because a bytes like object is required, not an element. A type like object is required. I don't get this whole code thing. Suppose we have to go through the XML documents. XML this thing, feed XML this thing, and then let me zoom in. Okay, so we got this thing. I don't care about this thing. So if you already know about XML, you can skip this section. XML is a generalized way of describing hierarchical structured data. Yeah, it's like sections and they have like subsections. Like if there is a person, then inside of this tag, it will be the qualities of that person or something related to that. parent tag. An XML document contains one or more elements which are delimited by stars and end tags. Okay. Okay, now this thing language, this is our attributes. Attribute names cannot be repeated within an element. Sure, we are not repeating it. So there is a matching end tag of the foo element. Element can be nested into any depth, right? 100%. Elements can have attributes with your name value pairs, like we have language and then this English, and it cannot be repeated. Attributes names cannot be repeated within an element. Attributes values must be quoted. Okay, I get it. So like I must have the text content, right? There is a shorthand for writing empty tags by putting / character that will make them just the single tag. What is this then? The feed element is in this link namespace. Okay, you can use an XMLNS declaration to define our default names with an particular. Okay. So this is the namespace and then the associated prefix with that, right? So what we need, what are we looking for? Parsing XML, that's what we need. Okay, so what they're trying to do is they're getting XML E3 element tree as E3. Then they have the tree e3.parse. They have the file in their XML, right? So they're parsing it, then they're getting the tree.getRoot, which is going to be the first element, right? So in our case, we were getting the first. The element tree library is a part of Python standard library in XML E3 element tree. The primary entry point of the element tree is a parse function which can take file name or a file like object. This function parses the entire document once. If the memory is right, there are ways to parse XML incrementally instead, right? As expected, the root is going to do this thing, root.tag, and so we need to look into this thing more. So, okay, right, all of this thing, go to help. We got e3 dot get root is the function that we learned, right? So we can say node in this case because this is our XML documents, right? So let's try N1. Okay, it's running. No response. Very good. e3.getRoot. Okay, it was UTF-8, but where do I see this thing? Okay. Yeah, getRoot. Oh, e3.parse is the function which we're gonna start with, and this thing is going to return us. Right. So first we have to parse it. Okay, so we got the E3, which is going to make us problems, right? The thing that I'm like getting confused about is that are they actually giving us the input? Because this thing right over here, system.standard input.read line, I don't know what this thing is, so I have to check. Define the between input and system.standard input, right? Python is a widely used general purpose language. I don't care about this thing. When input function executes, program will flow stopped until the okay, so until the user has given input, right? So we're taking input, the user is giving input. Okay, but what is this thing? Standard input stands for standard input. Okay, I read it. Which is a stream from which the program reads this input. This method is slightly different from the input method. It also reads escape characters input by the user. More, this method also provides the parameter for size, how many characters it can read at a time. So read line is the same thing as Nikhil \n. It can also read escape characters. In other case, input take it as a string and doesn't do anything with it. But system.standard input.read line, it actually takes the string and then actually parse the escape characters, and like just suppose here he's using \n, so it will present it as it will present it as a \n because he entered after like writing the name. Let's try. I don't want to sign up again. Forget about it. Okay, so he first took the input, and then he started the red, and then he converted into this thing, right? So they got the root. Okay, so they already have the get root function in there. So now we have the root function over here. Okay, this till now we have we have already solved it. So (1440p), man, that's like too much. Very good. Okay, well, so going back to the thing is we have E3, and then we have the, so it's already parsed and we already have the root of that XML file. But now we need to check that how many attribute it has, right? So the element tree library is part of Python standard library. This thing, okay, it takes it as object or file. Parse function is used to parse it. Then we can get the root of that file, or like the tree. Actually, it's a tree, you know. So local name, but elements are lists, right? So root.tag will give us the tag of that thing, but we need the attribute of that thing, not the tag, right? So they're getting the for child in root print child, and they have all the elements inside this thing. We can try this thing. So we have the node as a root for I in node, or just to be more descriptive, I can use child in node and child, right? One code. I should get these 4 in there. Okay, so we got element, title, subtitle, link, and update it, right? So this is the tags that I got, but I need to check how the functions that are available to me, each of these tags. So directory is used to get the functions that are like allowed to use, right? So I can check text tail. I don't want a tail tag, I already have it. Remove keys, either find items, inserts, okay, so for all of them. So do I need the text? No, I don't. Do I need the tail? No. Do I need the tag? What is the difference between a tag and a tail? I guess it should be the same thing. Make element keys. Suppose is searching for the keys. Bro, we need the attributes. Let's just search find attributes in XML parsing Python, right? Okay. So if we are able to get the root, find all / number. Okay, that is a different thing. Of a XML tag in Python, right? Okay, that is more of a related solution. So we got this thing, then we have the root0.tag is going to be bar dot attrib, and then we have the key. Interesting. Actually, it's not. Bro, why my stream is unstable? Like, really? No, 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 no. Okay, where is this?
I'm going Vayne.
Shut up.
You know what? I'm gonna go Vayne.
Bro, why I'm not going live? Okay, that is not okay. Go back over here, channel. Right, I should be live. Stream manager. Okay, we are offline. What the actual heck? Bro, actually it's so difficult to diagnose this thing, first of all. Okay, that is unstable. So what should we do then? Whoa. Okay, we can somehow go over here, adding settings, and then we can do nothing. Okay, just one more thing. Should be going live. Okay, I just Let's just refresh it again. Do we have any streams coming on? Why is it saying unstable? Video stats, no. We need to get something like offline, live, hideout, powered, bitrate. What the heck is this thing? Settings, stream. So we need to say like latency mode is normal latency. Okay, normal is fine. Okay, that is enough. You're live, okay, but this is saying you're live, but actually I'm not live. Oh, you're back. Okay. So once we have the child node, right? Okay, so what we have to do is we have to write print child 0, which is going to be what? Child 0 child dot tag. Oh, we are already in there, right? So we don't need the index for that. So this thing should be dot child dot attrib key. Okay. No output. Oh, because we're not printing it. Dumb. Not me. Index out of range, children 0. No, then it's out of range, right? For I node, we can just say like okay, somehow what they're trying to do is they have the foo bar. What they're trying to do is that for child in XML, which is going to be the already a string, right? Okay, this is the exact thing that we're looking for. So what we need to do is that for our first thing, we don't have any of these things. And if length of this thing is equal to 0, then what we're gonna say is we're not going to add anything to our. If it is not equal to 0, what we're gonna do is we're gonna add plus equals to length of the I dot attrib, right? if it is not equal to 0, right? Right. And at the end of this function, we can just say like print add. So the total score is going to be 3. So we have 1, 2, 3, 4, and 5. So what we are doing here? What's going wrong? What is going wrong? Some weird functions they wrote attrib. Okay, so we have 1 over here, 2 over here, 3 over here. So and then there's going to be 1, 2, 3, 4. Right? So what about the okay, so let's just check the node.attrib. We can also do this thing, right? Add plus equals to length of node.attrib, which is going to be just the feed, right? And let's try it now. So we got 5 and then we got none, and we also got this thing, right? Let's just do return add, stop printing this thing, and we will be good to go. Your output is 5 and it needs to be done, right? So we also need to check if there are any nested, I need to read the documentation xml.p3 here. So we got get root is going to be the root.iter. Sheesh, where it is. Okay, now we're getting one more of this thing. Okay, I didn't know. I don't know how I solved this thing. The view keyboard quality is going to be the, let's put it on source, low latency video stats. Bro, I don't know, like, I thought it was 13, but actually it was. Oh, okay, so I have to go back. Forget about it, bro. Stream manager. Okay, so it cannot stream in this, no. Not easy for this thing. Bro, I'm like trying to get the, okay, I need to fix this thing. Bro, why the heck is this not working? Yeah, here the stream is healthy, like. Okay, we'll look into that later. I don't want to mess my stream now. So this is going to work by itself. I don't know. Okay. So I need to check what was this iter print I. So we got the feed, title, subtitle, link, and updated, right? So 5 titles for going for this one. We should be getting 11 elements. Do we 1, 6, 7, 8? Okay, so we're at 8. But we were checking over here if len.i.attribute. Okay, so we got element feed. So we got subtitle with the language, element link with this thing, and this thing with this thing, and nothing is in there. Very good. Okay. We need to check into this. Let me just learn more about okay, I'm not live anymore. Okay, so let me just send more stream now. 1, 2, 3, go. Okay, we are live now. It should be live now. Okay, why is it black? Why the hell? Oh yeah, I guess it was not able to render the 1440p, but now it's fine. 1440p. I guess it was not able to render the 1440p pixels. Bye bye. Okay, okay, let's look into something more of so we got 32,750, right? So what was our previous Oh, 32,000. We dropped back. No, I mean, it's still the same. Okay, we can actually build up XML parser, you know. Tag is equal to text. We got functions. Tag is equal to text. We got functions. Okay, spin right. Okay, so we have to go back to the. Okay, so we have to go back to the. Okay, snap score is doing fine. Snap score is doing fine.
Manager. Manager. Karışık bakalım.
Oh, again, actually. Oh, again, actually. Okay, well, so okay, well, so Coffee or tea? The captain has a second family in Amsterdam and his wife on board has no idea. Coffee or tea? The captain has a second family in Amsterdam and his wife on board has no idea. Well, snap score is done. If I'm getting done with TikTok. Snap score is done. If I'm getting done with TikTok. Because there is a whole thing on this thing, Amazon architecture, right? Because there is a whole thing on this thing, Amazon architecture, right? Okay, I have to stop this here. Good job. So Amazon helps the cloud be secure, high performance, resilient, and efficient. So it's high performance, resilient, for ready publication workable. Built around 6 pillars: operational excellence, security, reliability, performance, efficiency, cost optimization, sustainability. So these are the 6 pillars that is my notion. Was preparation 20 December. Okay, right. We were going to do this in AWS. Right, let's just switch it to H1 heading, and then we have this thing right over here. So from here we can say that 6 pillars in AWS well architectured is going to be, one is going to be the operational excellence, right? Then do we have the security, reliability. So operation excellence, security, reliability, and then we have the performance. Of course, we don't want slow systems in place, no slow systems. Efficiency, cost optimization, and sustainability. Or performance efficiency, cost optimization, and sustainability. This is going to be the cost optimization, sustainability, right? So sustainability, cost optimization, reliability, and security. So security, reliability, cost optimization, sustainability, operational excellence, performance optimization, performance, security, reliability, and operation excellence, of course. So operational excellence, reliability, cost optimization, performance improvement or performance efficiency sustainability. So as OSRPCS. No. Security, reliability, performance, cognition. Okay. The OS well architecture includes domain-specific lenses, hands-on lab, and OS well architecture tool. The well architecture tool at no cost in the OS management console. OS well architecture tool. Okay, so OS. What is the function of OS architecture tool? Right. A good question, actually. We can go with the heading 3, right? This is a subsection of this thing, right? So the function is that it allows you to create, to check for there is a hands-on lab and the Oswell architecture tool available at no cost, and it provides a mechanism for regular evaluating workloads. So basically it's allow you to evaluate workloads and identifies high risk issues. Okay, so OS architecture tool, and it's also free. It's also no cost or free in the OS management console, right? So we got so like also they have 6 pillars with cost optimization, operation excellence, security, reliability, sustainability, right? And then there is a tool called OSQL architecture tool that is available at no cost. It allows us to evaluate the workloads, identify high-risk issues, recording improvements, right? Framework overview. Key concept, designs, principles, architecture, perspective for designing workloads. And by answering a few foundational questions, learn how well your architecture is. Okay, I'm going to take a break at 9. The Oswald architecture framework. Okay, so operational excellence, security, reliability, sustainability, performance, efficiency, and cost optimization. These are like 6 things. So cost, you need it. You want sustainability, reliability, performance, and security and operational excellence. Focuses on running and monitoring systems and continually improving process procedures. Key topics including automatic changes, confidentiality, and integrity of data. Okay, so key topics include confidentiality, integrity of data, managing user permission, establishing controls to detect security events, right? Reliability is focusing on work performing their intended function and how to recover quickly from failure. So reliability is like, so like if you have 2 data centers, right? Like, sorry, 2 availability zones in which your data is replicated, and one of them is like somehow destructed, and then you can just recover your data from the other availability zone, right? So it's more reliable than just putting your data in one availability zone, right? So if it's replicated in more than 2, it's more reliable, right? Okay, so That is like focusing on work environment and how to recover quickly from failure to meet demands. Key topics include distributed systems, recovering planning, and adapting to changing requirements, right? Performance efficiency. Okay. So, well, the efficiency pillar. So, like, basically, like, in efficiency, we care about how much faster it will be, or your code or whatever. Your architecture should be faster, or optimized. You can say that optimized. The performance efficiency pillar focuses on structured and streamlined association allocation of IT and computing resources. Key topics: selecting resource types, size optimized for workload requirement, monitoring performance, and maintaining efficiency as the business needs evolve. Resource types: what type of resource you're using will be growing the performance. Right, trying to get this thing, it's kind of okay. Cost optimization will be that the cost optimization focuses on avoiding unnecessary cost. Key topics include understanding spending over time, controlling fund allocation, selecting resources of the right type, and quantity and scaling to meet business needs without overspending, right? Okay, so the main thing is scaling to meet business needs, but don't overspend money, right? So like save money and get the task done. Okay, so like sustainability and reliability are kind of like similar, but it's not similar. It's kind of similar, kind of not. Well, where is my architecture? Focuses on minimizing the environmental impacts. Okay. So it's more of environmental than an actual zone based or like structure based of the availability zone or the region. So reliability is like replicating your data so it cannot fail, your architecture doesn't fail to provide the user what it needs. Sustainability focuses on minimizing environmental impacts of running cloud workloads, clear on shared responsibility model, sustainability, understanding impact, and reduce downstream impacts. What is a downstream impact? I don't know. What is a downstream impact? Right? For example, people as the total downstream sessions caused by members' action on the product. Relating or to or helping at a later stage in the process, right? So basically, it's more of like I don't know. Okay, so it's like fulfilling the business needs without overspending is cost optimization, right? Okay, not pulling, it's fulfilling. Okay. Oswald architecture lenses. Oh, so they also have a Twitch. Okay. Going back to our main thing, which is this thing, right? Oswald lenses extend the guidance offered by Oswald to specific industries and technology domains such as machine learning, data analytics, serverless high performance computing, HPC. What is HPC? We're gonna search here because we are curious. What is HPC in AWS, right? High performance computing. Okay. Run your large complex simulations and deep learning workloads in a cloud with complete suite of high performance products and services. Like they have like more performance optimized or high processing power computers or servers. Okay. No, I don't need know if this data paper is involved in the cloud practitioner. Let's just read all of them. Data analytics lens. Okay, so it's like Oswell architectured through the lens of data analytics. I'm assuming it's that, right? This paper describes the Oswell architecture data analytics lens, a collection of customer proven best practices for designing well architecture analytics. How to use this lens is the document describes the Oswell architecture data analytics lens, a collection of. Okay, this is 9:06. I'm just gonna take some break, Okay, let's just go back over here. Okay, it's downloading, so yeah. Okay. Best for designing and operating reliable, secure, efficient, cost effective. Okay, so the point here is that the person who was writing it, they just copy pasted all the 6 pillars of the architecture, right? It provides a way for you to consistently measure your architecture against best practices, right? Okay, we got a video right here. We need to add it to our source, which is going to be right over here. Let's just add a video media source, right? We can still like break screen, I guess. Browse, download, go over here. Okay, you can just say like oh, I guess yeah, why is it not in loop? Properties, local file, you have to loop it. Yes, we have to loop it. Sorry. Lock it. Okay, I'm just going to take a break for some time and then I will be back. Okay, I'm back now. So what we were doing, I mean, okay, let's just go back and see if we were doing so. What? Lo-fi is also copyrighted. Bro, you cannot play anything, like it's crazy. Like what the heck? Bro, who wanna listen to this? Oh, we got 6 views. I mean, this stream current bitrate is lower than the recommended bitrate. We recommend. Okay, bro, now you're gonna start doing it. Really? Let's just play some shell. I guess 1080p is also fine. There is everything is unstable. Okay, let's just play some shell shocks, you know. I knew he was there, but I still got killed. Killed me. No, I don't want to go there, man.